This is Search Every Word on NYC Streets, and I'm going to be talking about my hobby project, All Text in NYC, which I finished last December and started last March. It was put on hold for a while because I didn't know how to do certain things, but now it's done. Like NYC is done, and you'll be able to do the same thing, but maybe not. Well, not a lot of data will be processed in this session, but if you keep doing for longer period of time, you will have the same data set. So a little bit introduction about myself. My name is Yufeng Zhao. For Mandarin speakers, Zhao Yufeng. I'm a media artist and technologist at the intersection of art and technology. This is a cliche to say, so I tend to say ACL and J, aka Broadway Junction. I live really close to that. But really, my practice sits in between data, graphics, and experience design. I'll go through very quickly some of my work to show you what I mean by data. A long time ago, I built a data visualization about all digital cameras. I'm a camera nerd. This is a documentary project about Chinese big data infrastructure. That project is a whole data set of all the banner ads on the internet that one of my friends is doing a PhD on internet archaeology. So this is a joint effort of archiving everything. And this is a joint data between file extensions and airport code. There's a SQL, there's an SQL in the Bay Area as an airport name. I don't know, I've never been there, but it's fun that SQL is near Silicon Valley. I do a lot of graphic stuff. These are 3D graphics project that I've been working on. And also experience design. I did installations, just design works and immersive stuff, which is my undergrad background. So all of these three combined, I think it's the perfect reason why I was interested in the project. I just thought that I could do this on my own with like current computers, and I just thought of this idea and I could do it, so I did it. So before I start explaining about what the project is about, you can experience the project right here. If you type in alltext.nyc, which I'll go to this website right now as well. So if you type in any word, you can just see the Google Street View entries for all these texts. It's taking a while. One Way has a lot of matches. There's 800,000 matches for One Way. It's probably the most seen word on Google Street View. And you can go to other pages. There's like, I don't know how many pages. And there's also a data visualizer for a different view about the data. This is going to take a while to load, but these are all the One Ways in New York City. It's really taking a while. Earlier today, I was working outside for lunchtime, and I thought, what's the best keyword for like looking up Long Island City? I thought amenities, because I see that everywhere for the new apartment and stuff. Oh yeah, this is all the One Ways. Is too many. Let's try amenity. Am I spelling it? Yeah. Okay. You can see Long Island City. You can see downtown Brooklyn and other places. These are where the amenities are. Amenities and amenity. Amen. If you click in, you can see what they are. Well, this is probably a false positive. The OCR algorithm is not perfect. Okay, let's get back to the deck. So all the texts in NYC seen on Google Street View, about 8 million images from 2007 to last year. Full text search engine and also a geospatial visualizer is what the project is. And there are a few steps that I have to take to get there. Data managing, a lot of data, text recognition, OCR, data scraping, 3D visualizer, and dealing with panoramic images. And also the website looks pretty cool, which is, I designed the website as well. And before I start, I want to say that Google owns the copyright of all the images. And Google explicitly say, do not create data set from their images. But also, I think I'm not earning any money from this project, so this is technically fair use. But this paper go through all the legal problems that you might encounter dealing with Google Street View images. Well, in the US, there's fair use, but in Europe, there's not. So if you're a European researcher, the story might be different, but I don't think there's any legal action that fell through from Google for any researchers yet. So there's also another project related to this that I'm going to talk about the later end of the presentation. So data scraping, how did I scrape the data? I have a GeoJSON for all 5 boroughs, and I just sampled points on the latitude and longitude every 5 meters. And for all of these points, this is a very inefficient way to do this. But for all of these points, I query Google, what are the street views around this, and dedupe all the duplicates. So I pick 5 meter as an interval, although Google says that the API returns 50 meter radius, but it's not true. Like I've encountered a lot of missing data if I dialed the interval too big. So there's 41 million coordinates sampled, and it took me 4 days to just run it on one computer, query all the points. And this is the data, this is the stats from Google's Street View image catcher. So you can see like there's a pattern to it, but I don't know, like some years they capture less, some years they capture more. Last year is one of the lower years, but 2023, they really didn't do much Street View capturing. So after you get all the IDs for the panoramas, you can download it. There's not an official API to do it, but there's a way to do it. You're gonna see there's a bunch of GitHub open source project that allows you to do this, but I don't recommend doing any of the things that I say in this workshop legally. But you're gonna get a 16K by 8K image, which is pretty big, pretty high res. And how do we go from here? Because you can't just run OCR on this image. This image is a 2x1 equirectangular Mercator projected image, which is think about a world map that's flattened. So on the edge, you see all text are distorted. So I came out with a solution where I take a bunch of pictures, and then all the projected image will become a plane image, and I OCR the plane image and map the coordinate back to latitude and longitude, like the polar coordinate on the equirectangular image. So the configuration I pick for my project is I take 16 images, and they're all overlapping with each other a little bit. I'll explain the reason why. All of them are 45 degrees field of view, and there's only a 22.5 degree gap because I want the overlap. Each of them are 2K by 2K in pixels, and the OCR results will be mapped from XY coordinate back to polar coordinate based on the perspective of individual images. So this is why we want overlap. If you don't do overlap, this Broadway will have 2 results. One is broad, one is dway. And if you have an overlap, you can dedupe from the center one. I have an algorithm, which the first time I use a GIS thing, I use GeoPandas to calculate the overlap of the bounding boxes of the OCR. Why GeoPandas? Because these are spherical areas, and they're cyclic. So if you're on the edge of a thing, it's easier to treat all of these as an area on the globe rather than just a rectangle. So I use a GIS thing for calculating the overlapping area. And there's some algorithm going on. You're going to see in the source code today that it has certain weights on the text similarity. It prefers longer text, and it thinks different bounding boxes are overlapping with each other when the ratio exceeds a certain point. So how do I map it back to polar coordinate? These are all on the left, X, Y, width, and height are all the information you got from a plane image OCR with some math if you know whether the camera is pointing and how many pixels means 1 degrees. You can reverse calculate everything back in polar coordinate in the unit of degrees. So the width and the height, which is 3 and 1, means it's 3 degrees wide and 1 degree up. And I built for this OCR workflow, I built a separate package, a separate library, open source called Panel OCR. Not specifically tailored to Google Street View. You can just upload any, put in any panorama images. Like this is one that I took from a 360 camera around Bushwick where I live, and it recognized the thing. And you're gonna see this interface in today's workshop too. So the workload of OCRing everything I was running on a Mac. The OCR algorithm is why I picked the Mac. There are many OCR algorithms on the market that you can pick, but I wanted to run it through all the data, which is pretty big, and it better run on a GPU or some accelerated processor. So setting up, have any of you set up a CUDA thing for machine learning model and stuff? It's not very fun to get a Windows machine working, have a GPU model working properly. Especially you don't own one and you want a cloud one. It's kind of a hassle to set up the environment. So I benchmarked the Mac built-in OCR results when you, if you have an iPhone or have a Mac, if you open an image on a preview, it automatically does the OCR thing, and that's the built-in OCR engine that's actually not running on the GPU. I think it's running on the neural engine on the Mac processor, which only Mac OS is allowed to use. So the workload of everything is 1.2 year M4 Mac Mini. That's the unit. If you have one M4 Mac Mini, it takes 1.2 years. And I got 4. So it took me around 3 months to get through all the data. And I thought I was done, but it was October, and October, Google did another capture for last year. So I wasn't done, and I kept going. And here we are with the search engine. You can search all kinds of stuff. These are all the Broadways, and if you do the geo visualizer, you can see the Broadway patterns are on the Broadways in different boroughs. And this is Broadway. These are just some examples. This is Love. A lot of them are from a Popeye marketing campaign. These are free stuff. These are NYPD. A friend of mine suggested to search this one because it doesn't really make sense to find NYPD with this because they only capture once a year. But maybe it makes sense to see where NYPD is not in the city. So this is west. This is east. This is one way. You already seen this. And these are the word cloud from a portion of the data, not all the data. So most word is one way, second stop. Well, third Google. Google has a little watermark on their images, so that's why Google is here. These are some just fun examples. White supremacy. Remember love. F love. Happiness is here. 6 happiness. These are, somebody did this in a row sometime in when was that? 2022. It says deport Trump on every single one of them. These are all the MoMA tote bags on New York City streets. If you search MoMA. And this is the project. And I also did some spin-up projects around the data set that I already have. ThereisonlyoneWay.com is a project that I made for this event, which is LARPA is an artist studio around the Bushwick area. We're really close to where I live. And I did just a data set of one-ways. If you go to thereisonlyoneWay.com, there's only one-way signs. And I also printed a few card. Because the event is about selling small batch data set, I printed gift cards for redeeming the data set for one way for your borrow. So there are 5 different types of cards and you can redeem them, and it's scratch out card. You can just scratch it and go to my website. You can redeem the CSV file. That was the project. And this is a different project, a collaboration with Maury, who's a creative technologist and media artist too. He famously made the project Traffic Cam Photo Booth. I'm not sure if you have heard of it, but this is an ongoing collab. We're doing a project where if you visit it at 1913 7 p.m., you're gonna see a 1913 in the website. So it's a clock. This is I'm not the first one that who thought about using Street View data for to extract text. So spatial analysis lab at USC SLAB, the leading professor is Annette Kim. They did a project a long time ago, I think in 2017, scraping all the Google Street View in the LA area to map different ethnic groups in LA. So there are, I forgot the exact numbers, but there are a lot fewer officially recognized Chinatowns than actual Chinatowns. Like San Gabriel Valley is absolutely a Chinatown, but it's not technically officially a Chinatown. And the project is called Ethnicity. And they had a similar problem with Google Street View. I think Annette Kim, Professor Kim, she asked Google about, can we use your data? And they're like, we're not allowing this, but if you do it and not tell anyone about it, I think it's fine. And they also did the OCR using Google Cloud Service. So it was much, they have funding, so it's much faster than this. They're looking for, like for Black communities, they're looking for words like soul food, but not just the word in the ethnic group's original languages. So it's a really fun map to look at. And also, before we go into the workshop again, to use or not to use preparatory Street View images, it's a question you're gonna ask yourself. And let's go into the workshop. If you have a laptop, the QR code doesn't really make sense. Your phone is not gonna do Python, but the GitHub repository is yd3440/GSV text scrape. You want to have Python higher than 3.8 because I have type annotations in it to help keep my sanity. And you need internet access along the process. And a Google Cloud API key that uses, oh, by the way, I didn't pay Google any money doing this project. I didn't have to because all the website, I didn't host the image, and all the Street View that you see on my website is a iframe that I use Google's API to embed, which is free. So if you have a Google Cloud API, you can do 2 more steps in the workshop, but if you don't have one, it's fine. And also the API that we're using is free. And also Google has a $300 credit for every month for map services. You guys are gonna be a lot slower than the Mac users because I don't have a GPU accelerated OCR thing going on for Windows. There's a few CPU solutions that you can choose to use. If you look at the GitHub repository already, there's a lot of different requirement packages that you can choose from, depending on what OCR engine you want to use.
Which of the repos in here are required?
GSV text script. Yeah, I have a few, and GSV text script is an aggregated one that I made for today. Because for safety reasons, I separated the scripting code and the OCR code, just so the OCR is not tied to just working on Google Street View. Cool. I'm not sure what step you guys are at, but this is the repo if you have one. So under the GeoJSON, I'm gonna make this a lot bigger. If you already have the repo, open it in text editor, obviously. The GeoJSON folder, I already populated one GeoJSON for today. This is like around like a few blocks around this area, the CUNY Law School. If you want to pick your own, in the README, I wrote a pretty comprehensive README file for this repo. That you can go to geojson.io to draw your own GeoJSON. Maybe I'll just draw a smaller one right now. So if you go to geojson.io, you can just draw a rectangular bounding box for a GeoJSON. Wait. Let's see. Oh. Yeah, you can basically pick anywhere. I'm just gonna draw a very small area. I don't know, Grand Central. Maybe I'll move it down. We'll just go to cover Grand Central. Okay. And I will just copy this part. And paste it here. And this one is important. In the property field, if you're using your own, just put a random name there, because the code, depending on having an ID for every single feature, and you just need to give this feature, this bounding box, a name for it to populate an ID. And I'm gonna delete my database for now. Oh, and all the data that this script generated is gonna stay in the SQLite database in this folder. SQLite, anybody don't know what the SQLite database is? Okay, cool. It's just a single file database that takes SQL queries. So the default path for the database is gsv.db. And the first thing you want to install, I already have it installed, is let me reference the README, because that was the okay. Step 1, you want to pip install r requirements-scrape. These are for the scraping to get you started. And if you have this installed, run the following code. And oh, that's fast. It's really small area. And I also dialed the interval from 5 meters to 25 meters just for this workshop. If you want a more granular result, you can go into the code and change it yourself. This is 25 meters apart, around 1 block near Grand Central, just 98 point. I'm sure there's going to be some results there too. And if you run, that was the script 1A. And if you run 1B, it's going to try to find all the street view around that area, the 68 point, 98 points. And surprisingly, this part doesn't require an API key, because Google Street View, if you don't log into your Google account, you can still access it. So that's just an exposed API. And if you want to run 1C, you will need a Google API in your .env file. 1C is to get all the metadata for how many results were there? We already have all the IDs for the panoramas. Let me show you real quick on GSV. We already know where these things are. Oh, this is just a point. Sorry. Let me switch to a different table. Here they are. So in the search panorama, oh, sorry, the text is so small. In the search panorama table, you're going to see all the already scraped panorama. And you see all the data. This is the ID that Google internally uses. Bunch of gibberish. And latitude, longitude, date. Sometimes it doesn't come with date, just because some weird limitations about this API. So if you have your Google Cloud API, you can query the date specifically and the copyright information for free. And you might be wondering, why is copyright there? Because Google also takes community contributions, and also different entities, like private companies, can contribute to Google data as well. So, but most of the copyright information is just, copyright, the C mark thing, and Google. Not that interesting. And the heading, pitch, and roll are the heading angle offset from north when the car was capturing it. The pitch and the roll is just the offset, like the car is driving recklessly and it has a roll and pitch offsets. That was what it is. And the image is stored distorted like this on Google server. They don't actually correct the images. So these are some of the numbers that you need to account for when you are trying to pinpoint the text on an embedded Google Street View image. Because when you view all the Street Views on Google, it's always corrected. It's always, the up and down the horizon is correct, and it's knows where the north is. But you need to do some math to actually reverse calculate the heading that you need to put in the URL to get the actual heading. And the math is done in the code base already. And if you're interested, you can take a look. So 2 extra field here, computed OCR, download attempt. The script 2 is gonna try to download the image first and then OCR it, and it has an option whether or not you want to store the intermediate data. And by default, I don't store any of the data. I don't host the image. I don't have space for all the images. I try to download when I didn't have a good sampling script. I downloaded 300,000 Brooklyn tree views, and I thought that was it. And that took up 4 terabytes because they are pretty big and high quality images. But later on, I just delete all of them. And okay, if you are on this step as well, we're going so fast now. Like, anybody need help with this? No? Okay. Maybe we'll just do code reviews after this. This is so fast. Okay. With the OCR, it's more complicated. So you want to first pip install our requirement.ocr.txt. That's the general OCR utility that you need for any of the OCR code. And depending on your system, if you have a Mac with you, I recommend you just install the requirements -ocr-mac. And that will point you to a library called OCR Mac, which is a wrapper around the Objective-C API that macOS uses. And there are a few other options. For Windows user, I recommend installing the Easy OCR. The other options are Hugging Face and Paddle. Hugging Face and Paddle both has, well, Hugging Face because it's machine learning model based, so you better run it on GPU. And interesting story with the Hugging Face option, I think for the Hugging Face model, I was choosing the Microsoft Floron 2 to run the OCR. And an interesting difference between a machine learning based OCR and a traditional OCR is when you run it through a machine learning model, it doesn't give you back a confidence. It is like, look at where things are and then just give you what it thinks are the texts. And also they are too smart about languages. So they try to recognize everything into all the languages they know. So in the traditional one, you might, like in this case, and in my data set right now, it only recognizes English words because recognizing Chinese or like Russian Cyrillic alphabet will be a totally different path. So it will double the computation, and I don't have all the time for all of these. But if you feed it to a machine learning thing, like Florin 2 by Microsoft, is going to try to recognize everything as anything, any language that they know. And sometimes like some symbols just being picked up as Cyrillic letters, which is not great. I did benchmark all of these models, and I had some results that's not on this repo, but the only affordable way I can execute this project is by buying a bunch of Mac minis and running on the Mac built-in OCR. And so here we are. So Windows users, if you have OCR, Easy OCR installed, the default OCR engine for all the script is Mac OCR. So if you're a Windows user, you want to run Python 2. Let me make this even bigger. Python 2 --OCR engine Easy OCR. And that will pick the Easy OCR engine. In the library code, there's the OCR layer is completely abstracted and framework agnostic. Every framework I implement in a different way to interpret the bounding blocks. And like if you have dealt with OCR bounding boxes, they have different standards. Like sometimes they treat the top left corner as 0. Sometimes they treat the bottom left as 0. Apple, which is weird. If you run this, it's going to randomly pick from the database one image that's not being computed yet, and it's segmented into 16 images, the configuration that I use, and I run OCR in this speed. This is Easy OCR on my Mac. And this is not very, the code is not parallel. optimized. So how I did it is just I calculate how many terminal window can I have opening and not max out my CPU. And I have 10 open for each Mac Mini. But yeah, and it also runs a little benchmark on telling you how long each one takes. So if you want to oh, I haven't talked through the how do you see the data that you have scraped. So if you have done the first step, which is scraping the Google Street View, you can go to Python. You can run Python server.py, which I recommend just keep it running in a different terminal. And that will, oh, this is crazy. And that will lead you to, if you go to 8000, I'm using Rapid API, and it has an API endpoint and 3 different websites that help you preview what you have in the database. So preview database, this is just looking at what you scraped without the OCR stuff. This is all from your database locally, if you're looking at it on your machine. This is around Grand Central. I can see that. Checks out. Okay. And if you go back, the second preview function is preview the OCR. This is the interface that I showed in my deck, which asks you to drag in an image and a specifically formatted JSON, and it will visualize where the text boxes are. So to get that working, you want to run the toScript panel OCR -- save result. And this will populate a temp folder here. This is the result JSON. Whatever OCR engine you pick is going to result in the same JSON file, but with a different flag to signify what OCR engine you're using. I'll check it out. And this is the image. Is it the same ID? No. Okay, these two are the same ID. I'm going to grab this file. Wrong window. Okay, which one? Okay, these two are the same file. I'm going to drag and drop to the box, and it's going to show me what it recognized. Pretty good. Some of the boxes, a lot of the boxes are crooked a little bit just because there's distortions, and it might be like on the edge part of the image that it recognizes, so it's more distorted. But yeah. Oh, and one other limitation that this method has right now is I'm not taking photos of above and bottom because it doesn't, add a lot of value. And it also poses problems on the dedupe process, because right now I'm just like going horizontally, and I know that number 1 will only overlap with number 16 and number 2. But with top and down, I cannot assume, like there's multiple permutations of overlap possibilities. So, the computation for dedupe is exponential if you do that. Yeah. And yeah, this is not merged. Yeah, there's a lot of artifact with this the dedupe process, but this is a tricky situation. So if you've done a few OCR, if you keep it running like this, and you go back to the preview code, preview DB plus OCR is the OCR results that's directly from your DB. You don't have to drag stuff and all of that. Doesn't show you the bounding box, but this is the live, that's the TD. That's another TD bank. Turns. With a small data set, you can already start searching things. Let's just say one way. There's already one way in my data set. I'm not surprised. Yeah. Anybody having problems with the whole process? Okay, I did a really good job with the workshop code. I might do a code review for all of the things. Like, does anybody have questions about the technical details of the process?
I guess after.
Surprisingly, no. I have a 1 gig Verizon fiber thing going on in my home, and I upgraded because of this project from 300 megabytes. Yeah, it was fine. It was actually fine. And also the OCR is pretty slow, which means that you're not being bottlenecked by the download speed at all. So OCR takes, I think on my machine, I run 10 windows. Each takes like a minute. And I'm running at like 10 images per minute, which means that every 6 seconds I download one.
Oh,
Yeah, not too bad.
Would you do the same thing with object compression, like YOLO and that sort of thing?
I've not tried it just because I don't want to touch GPU code yet. And also I think text is like easier to, like it's more fun to do, just say I have a full text search on New York Street. But yeah, like YOLO, Isaac, your project earlier today, YOLO is pretty unpredictable in a lot of ways. And I tried, I haven't benchmarked the performance, and also the sheer amount of data is just too big. Yeah, I haven't tried it. I looked into it. I looked into a different YOLO model though. There was, I think it was called YOLO World or something like that, which I don't know how it works, but it asks you to give it a set of label, and it tried to match that label. So if you can give it a label taxi, and it tries to label things as taxi, which is pretty crazy. I don't know how it works, and I didn't try it. I tried on the Hugging Face preview portal, and that was it. But yeah, YOLO would be really fun. Really fun. But also you can find a lot of objects based on, you know, what words are adjacent to it on the website already. What's an example? Stop. Yeah, stop is mostly stop signs. Just some more hilarious ones that I can find all kinds of stuff here. Stop is also really slow. But I do cache the results once for 3 days once you run a really slow query. So if somebody searched stop yesterday, it should be faster. One way is pretty fast now because I already searched it. Stop. It recognized upside down text, which is pretty amazing. Using the same method, I'm also done with Hong Kong, not the mountainous like suburb Hong Kong, but just like Hong Kong proper. The results are really bad. First, because the language is mixed. There's traditional Chinese, some simplified Chinese, and a lot of Englishes. The most problem is for the same amount of pixel, it's easier to make out Latin alphabet than Chinese characters because it's more dense visually. And there's a lot of false positives. There's a lot of there's wrong characters around. And wrong characters is more destructive to the reading experience in Chinese than English. So yeah, I didn't publish it. But all text SF. This is I didn't publish it anywhere, but this is up. I also did the same thing with SF. SF is pretty small compared to all of New York City. I also did Staten Island, which is a lot of the panorama just doesn't yield any OCR results. It's just houses. But yeah, a fun word to look in SF is cloud because it's advertising billboard everywhere that says cloud. As for developer, ROI that will make you say OMG. Love is blind, data is not.
these are all the tech companies advertising.
If you search cloud, yeah, like you need to be smart about the keywords to summon these. But yeah, if you're in SF, these are pretty ubiquitous everywhere. And like I moved out from SF 2 years ago, and at that time I can't. Like I work in tech. I'm a software engineer, and I don't recognize a lot of the jargons that they have on the billboards, which is problematic. It's like
time did it take to process San Francisco Bird 3?
it's a lot faster. I forgot the exact. So it's linear to the panorama count. I don't remember the number.
Is that really the number or file flow?
Also depends on, okay, so depends on the area, depends on how dense Google takes the photos, right? I think SF is pretty dense. Like Google launched Google Street View 2007 with a lot of photos of SF. And but it's also small, you know, so there's like, because it's small, so it's a lot fewer, but probably it's more densely captured. Yeah.
First about that check cop is there Google is that coming from you or is that coming from the
Oh, confidence is from the OCR engine. And I use the OCR engine that give you the confidence. Oh, I forgot to mention there's a filter functionality here. You can choose the data range and the confidence level, both the minimum and the maximum. What would be a fun thing to search with given a time period for New York? Like any suggestion? Snow? Okay, this one, okay. Let me explain this one. You don't see any snow immediately like around the center of the frame, which means this photo is taken down by Google. And automatically, if you're using the API, it try to match the closest photo and pointing it to the same angle that you ask it to, which is completely the wrong angle if it's the wrong photo. So this is inevitable. Like I don't know what Google is doing with their image.
question? Have like a very specific text that maybe only appears in one place. Do you think that you like be able to reliably, repeatedly get only one results from say like one of the billboards that you had that we ripped out would probably
Oh yeah,
only billboard that out there is that
interesting.
only get one result back every time you search back specific.
Let's say SAP Sales Cloud. Oh yeah. I mean, this obviously it'll work. The full text search is not that reliable because SAP Sales Cloud and Sell More Faster, these are completely two sentences that don't know about each other. So if you want to search the full sentence is a problem. And area of improvement, but I don't know a performant way to do this. It sounds like a lot of computation. I'm paying $60 a month for the server I'm running this. The data is like 10 gig and all of them, all 10 gig of the data need to live in the memory. So you need a bigger server. But I'm also hosting all of my other projects on the server, so it's fine. Yeah, there's a few billion rows for all of the OCR results, so need a beefy server. Snow. One interesting thing I like to look up is best pizza. Some shops claim they have the best pizza. And these are the best pizza. And if you just search best, you're gonna see a concentration of best things. And those best things are it's not loading. There's a lot of best. Okay, yeah, I think these are Best Buys. Yeah. So because Best Buy signs are pretty big, it will be seen by more photos, and therefore there's a concentration. But it doesn't mean that there's more best there. So another limitation of if you want to get a reliable, source of textual research, this is a limitation.
I searched on Wu-Tang and I found a bunch of graffiti in Staten Island at Mark Art Studio Bus Square.
You say
Oh, right. Not quite. Oh, graffiti is fun. Like if you search profanity in the search engine, you're gonna find a bunch of stuff. Yeah, what's a fun Palestine? We can find a few. I think it's crazy that it recognized this, and this is the Mac built-in OCR, which I'm pretty impressed by.
Have you thought of using an LLM to caption instead of OCR and then embed that into a semantic search against them?
No, it just, again, I don't have the funding to rent GPUs to do this. So, I'm not even thinking about it. But yeah, it's a possibility. And also merging objects will be a fun exercise, dedupe between the frames. Because technically it has more information. If it's a car in this frame and that's a car in that frame, like you should probably merge those. But if it's just a text and another text, it's less obvious that you should be merged.
I searched for Dell at the computer company, came back with mainly Dellies.
Interesting. So the full text engine is using PGU vector under the hood. It runs on a Postgres database, and it has an English dictionary built in. So it tries to do fuzzy search all the time. I think.
Go to the magnifying glass, you'll see 6 bellies.
Hold on. Dell. Oh yeah, this is tough, right? These are all kept Delhi. But yeah, there's a lot of false positive in this case. But if you want to search exclusively just Dell, I don't know if the logo will be picked up, but there's an exact match mode in the drop down here if you just want the word Dell. Oh, I have a bug. It's using the cache result even if you toggle it. Okay. Let's open it. Let's start from the stock side. Apply. I forgot to click apply. That's my problem. Dell. Exact search. Apply.
I'm not sure you have a bug. I think the BOCR engine is recognizing that lowercase that I is.
Yeah. I was saying that the exact match had a bug, but it didn't. It's me not understanding my UI design. I don't see any Dell, but you see a lot of if you search iPod, there's a bunch of iPod ads around. Is that one? No. Wait, what is this? And one interesting thing is, like, I grew up in Shanghai in China, and one thing that I know the US never had in VCD, never took off in the North America, but VCD as a format between CD, but it can play video, but only 2 episodes of TV shows, took off in East Asia. So if you search VCD, you're gonna find all the VCDs in Chinatown, where Chinese people live in New York City, which is pretty fun. We have a lot of time left.
Have you looked at time trends of different search terms? Very example is like cloud make you think.
Yeah.
If you were to search cloud only in 2014, you probably see a lot less.
Yeah, I don't have that visualization tool yet, but if you keep note for how many clouds we see in SF, we can do it. We can try to plot it now. Let's see, cloud, and we limit it to it's getting small. Just 2017, 2018. This was the only cloud. From 2018, from 2008 to 2010, we see a first cloud. Salesforce. Oh, and also, I don't understand the image blurring policies by Google. This is blurring a trademark, but most of time they don't do it. Okay, another 2 years. Oh, same one. Come on.
I don't think Google's consistent. Like, I know somebody that had their picture taken in Google Street View. They call Google and they blur the space.
Yeah. They do take requests. That's what I know. Okay. 2012 to 2014, we see 2 cloud by IBM. It's from the same ad campaign, which is another 2 cloud. This one is not it. Yeah, these are not it. Yeah, and because there's basically for each geolocation, there's at most 1 or 2 sample point every year. So it's not a super representative. Oh, I think I've seen this one. This is early. It's been there for a while. But yeah, definitely more cloud as it goes. Okay. So we got no question for the code at all. Great. The workshop code is taken from 2 libraries that I wrote. Not exactly a library because it's not like plug and play on a Python package manager, but one is NYC GSV collector. There's only scrape stuff, and I use it to scrape the SF. There's a branch in this called SF. There's a branch in this called Seattle. I think Hong Kong as well. You just plug in different GeoJSON and call, make sure that the district name matches the code, and it recognizes the district in Hong Kong, different like prefectures in Tokyo, that kind of stuff. And the other library is doesn't ask you where the data come from. Also doesn't help you download Google Street View in case you have a 360 photo. It does the same thing for you. Cool. Where do we go from here? More search result. Best bagel. Also did that. Did I clear the time? Yeah. Some of the best bagels on here. Anyone been to any of these, please?
It was a little bit that thing wall. That was just it was a bit the bite.
What else? Oh, one in Staten Island. Yeah, best bagel in town. Oh, it's on the side. Motivation. Oh, I just figured out that I can do it, and yeah. Oh, let me show a different project right before this. Banner Depot 2000, and you will see like these 2 are identical project, basically, but we're collecting data in a different way. BetterDepot2000.net is a joint effort between me, Yufeng, and Richard Loei Huang, who's doing a PhD at University of Washington in information science, and he's super into internet history in general, and his dissertation is going to be about the guidebooks for the internet. Like, how do we collect all of these ads? We have a pretty scientific approach. We bought published yellow pages back then for all the internet URLs. Like, you just buy a book that has URLs on them, and we scan. We bought Chinese ones, Korean ones, Japanese ones, Russian ones, and American ones, and we rip out every page, scan it, and write a different OCR workflow for each individual book. Some of the Japanese book had crazy arts in it. And we scan it, we archive it. And when he's doing research by querying these websites from the Wayback Machine, from Internet Archive, he found out that he's downloading a bunch of images. And these images, like most of them are just these ads. How we filtered it out, we download snapshots and then we see the images. And because Banner Ads has specific industry standard sizings, like 400 something by 60. So yeah, we have a data set of all of these stuff. And you can also do full text search. You can also do range search. And if you click open one, you can also see the metadata about this ads. This ads is Chinese one. It's scraped from this website at what timestamp. And also we we got a little creative with this project. It also can generate haikus from these ads for you. A new poem, haiku, voicemail, and faxes, live tour, sports community. You know what you want. Sometimes it makes surprising sense. So yeah, and we post it on Instagram if you're interested. Look these things up if you're interested. And this is my website. Last few minutes, let me just show there is only one way. There's only one way.com. If you go to this website, there's only one way. And every 20 seconds, it switched to a different one way. And that's basically it. And if you were in the event, if you bought my gift cards, which I didn't get the money from because fair use stuff, I donated to Internet Archive. And if you put in the code, you will get a CSV, and you can download it 5 times. Clock.alltext.nyc. I think this is it. This is a clock. And we're near the end of the session. Here's some more. Every time you refresh, it's a different. Yeah. Not necessarily address. Sometimes it's weird stuff. Oh, this one. Okay, this is removed. The image is removed. Then we need to filter this out. Cool. Manually. Yeah, my collaborator on this project, he had a Python thing to just look at the thing and yes or no, veto or all the results. But yeah, I don't know what's going on in this one.
How often are they filtered, or are they removed?
Oh, it's a one-time thing that we never got time to finish. We have a database, like this is the whole database, and we need to trim the database down. But yeah, the trimmed down database is not up yet. So, oh, what's going on in this one? Anyways, yeah. I don't know what to do with the last 2 minutes, but I guess this is over. Thank you for coming. Yeah, if you like the script, if you like the README, like star my repo. And if you ended up using it, just like keep it down from Google. Any of you from Google? Oh yeah, I had this project on for like 3 months now, and I didn't get any, cease and desist, so I guess it's fine.